In this lecture, we're setting up our rotation so we can rotate to the right and rotate to the left, and I'm going to use this as an excuse to do a little bit of an else if and also setting up some parameters and arguments in a method. Let's get started. Just a quick one that I'm finding a little bit annoying. When I click on the rocket, it takes me to the prefab game object visuals. It's underneath my actual parent that's got all of my Rigidbody and box collider and scripts on it. And when I click on it, I want to go to this higher level. I think what's going on here is I need to prefab my player rocket. So I'm going to open up my prefabs folder and drag my entire player rocket game object down into there. Now that's a prefab. Now I think when I click on that, yeah, it keeps me at the parent level. It's one of those quirks. I don't think that happened in past versions of Unity, but sometimes these quirks kind of sneak in and you only realize them when you go through a workflow often and you're like, hang on a minute, what am I doing wrong here? Or maybe it's always been the case and I'm just being a dunderhead. What do we want to do with our rotation? Well, you can see we're going to rotate around the Z or Z axis. And the reason I say that is that's the one that's going into the screen. And that's the one when I go to rotation, Z or Z, burp, 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 it rotates around that. Oh, but hang on a minute. Why is it doing that? It hasn't done that before. It's only doing it now. That's because we've got this relationship between our parent game object and our rocket inside it game object. And so if I was to click on my object inside and push that down a little bit, that'll be relative to the parent. So the parent stays at this position in the world, whereas the rocket or the actual visuals, the child game object, is now minus 0.4 lower than my parent game object. So that's a good thing to know. Children's coordinates are always relative to the parent, and the parent's coordinates are always in the world space. So now I've moved it down a little bit. We'll move it down a little bit more to see if this actually get an extreme example. Now when I click on my player rocket and rotate around the Z or the Z axis, okay, it's rotating way too high up at the top. We need to fix our collision box in a moment as well. So let's grab our child object, move it up a little bit. I think it's going to be around about there. Click back on the player rocket and rotate left and right. And you know what? I'm a little bit silly. Up in the top left, I believe if I click on pivot instead of clicking on center, that will show me exactly, yep, that's where we're pivoting around. So if I wish to click on my rocket, move it down a little bit, click back on my parent, and I'm still clicked on pivot, you can see that the pivot has moved up because it's relative to the overall mass of the game object that we've got here. So now it's pivoting more in the middle. Okay, sorry, it took a while. Should have clicked on that straight away, the pivot button up in the top left. Now let's just quickly tidy up our collision and move it down a little bit. Better get this guy above the launch pad. Okay. Good enough for now. Now let's talk about what we came here to do, which is to get the actual rotation happening. So over into our movement class, we want to scroll down and find where we're processing our rotation. I don't need my debug statement anymore. We'll get rid of that. What I do need to do is say, if my rotation input is a positive value, then rotate to the right. And if it's a negative value, rotate to the left. So we'll start by creating ourselves an if statement. So if parentheses, rotation input, that's our variable just up above there, is what? If we want it to rotate to the right, do we want it to be positive? So greater than symbol 0. That means if it's a positive value, it's going to do the following thing we want to tell it to do. This is where we're going to use our Transform.Rotate. So Transform.Rotate, parentheses, we need to put in here a vector 3. And if we go back and have a look at Unity, the vector 3, we're on our rocket ship here. The vector 3 is going to be to do with rotation. So we want 0 on the X, 0 on the Y, and something on the Z or on the Z. So we could type this as 0, 0, 1. If we were being good, we would put Fs in there because I believe this is going to be a float. And that should rotate to the right. So every time we process rotation, it will rotate positive on that Z or Z axis. There's another way to write this, similar to how we had another way to write vector 3.up. We can write vector 3.forward. And if you mouse over vector 3.forward, that says to us, mouse over it, that says it's the same as 0, 0, 1. So let's leave it at that for now. Put a semicolon at the end, save, jump back into Unity and see if that actually works. Click on play. Now when I zoom up in the air a little bit and push to the right, oh, I go the wrong way. Okay, I completely messed up. And you can easily see if I go back into my world, I can see that despite the fact that I thought it should be a positive value would rotate to the right, it's actually a positive value rotates to the left. That's okay. Just means we need to go back into our class in here. Instead of rotate, input is greater than 0. We'll make this less than 0. Click on save. Now back into Unity. Click on play and push to the left, and now we rotate to the left with the left arrow key, and the left arrow key is actually making it rotate to the left, which is what we want. Here's a little micro challenge for you. Set up another if statement so that we can rotate to the right. So pause the video and see if you can do that. Okay, there's a little bit of a tricky challenge. I'm a little bit naughty setting this for you, but hopefully you're a clever sausage and you figure this out. So I'm going to highlight my if statement, copy that, and then paste this down just below. If rotation input is greater than 0, you might have looked at this and said, well, what do I do now? You could go back in and say 0, 0, minus 1, or you could type in minus vector 3 dot forward. That's doing the same thing. It's basically saying apply a negative symbol to anything which is in here, and we know that vector 3 dot forward is 0, 0, 1, so therefore it's going to be negative 0, which is 0, negative 0, which is 0, and negative 1. Let's see if that works. Click on save, back into Unity. Click on play. Just a side note, I've got to change this camera soon. Yep, to the right, to the left. There we go. We're actually rotating. It's very slow. It's very awful. Boom. But it's going to be fun, I think. But it's too slow. We need control over it, etc. There's one other thing I want to look at with this code here, and it's an excuse to do a slightly different technique. I'll give you that, is that we've got this situation now that's saying if we're doing this, do something. If we're doing that, do something. What if we're doing them both at the same time? And logically, we don't think we can have a positive and a negative value on rotation input at the same time, but who knows? Maybe we could. Maybe there's some way for that to happen. So it's good practice to have a look at these things and say, okay, we don't want someone to ever to be able to do both of those things at the same time. And the way